All right, so lesson 72 here, we have linear fits from data. So, right, so this is showing an equation of a line based on data, and then we have negative angles. So if I'm given this, right, let me give some idea here of what we're going to do, some steps first. First, what do I need to do? Well, and we'll explain this as we go, but I want to draw a line of best fit. So I want to draw a best fit line. That's the first thing. And then if I draw that line, then I want to pick 2 points on that line. So pick 2 points on the line. Okay, so this is important that I pick on the line. I don't pick the actual data points. I mean, it may be the same, but I want to pick them from the line. Okay, this is important. And then, right from there, right, we know that we have equation of line, right? So what do I need to do? Well, I need to find the slope, right? So I need to find the slope, how slanted the line is, right? That's what slope is. Okay, so find the slope, and again, this is the letter M. It's also rise over run, okay? And you could also say that it is change, right? So again, this triangle here is change in y over change in x, okay? Not too complicated here, right? And then after I do that, then I need to find b, right? And what is b, right? B is where we cross the y-axis. So find b. So this is my slope intercept. My slope intercept. Actually, instead of writing slope intercept, I'll say it's my y-intercept. Okay, it's my y-intercept. Right, it's where it crosses the y-axis. And this brings me to our equation, right? What is our equation? Well, our equation says that y, which is our vertical axis, y is equal to m times x plus b, where y and x are values on the graph. M is my slope, right? So I'm going to find my slope, and then I'm going to find b, right? So I'm going to find this guy, I'm going to find this guy. So now, what does this look like on my graph? Well, let's just keep this in mind, right? Okay, maybe I can do, I don't know if I can do this, but I'll come back to it if I need to. Let's just make up something, right? So if I have an example, and I love weather, so maybe I can make up a weather example here, right? But if I have a graph here, and I have these tick marks here, right? So I have these tick marks, and this is temperatures maybe, okay? So this is like 40, this is 60 up here, right? So each one is 10 degrees, and this is 80 degrees. Okay, so this is temperature, right? So I could say this is temperature, right? So I could use a TEMP to label this. Maybe it's in Fahrenheit, okay? But we'll just keep it temp for now. And then these are the months of the year. So I have 1, 2, 3, 4, 5, okay? And I'm just going to say these are the months. So this would be January, February, March, April, May, okay? So these are months. And right, this is not real data here, but you can get data a lot of places, right? And so this is just an example here. So now, what might I see on this? You could have data scattered around here, right? So maybe I have the last, 20 years or something scattered on here. And so in January, my data is scattered like this. Okay, maybe I should make the dots bigger. I don't know. Let's see. How can I make my dots bigger? Oh, here we go. So I can make my dots bigger. And I'll come and make my dots better after. So my dots look like this. And so then by May, my temperature is warm here. Okay, and so then say, well, how do I fit this data, right? Let's go back to make this skinnier, and maybe we'll make this color a little bit different. Maybe we'll make it red. And say, well, I don't know, this looks pretty linear, right? Maybe I could have made it a little different here, but I could draw a line of best fit, so where I have something like this, right? And maybe I could have made that a tiny bit straighter, but whatever, it is what it is, right? And then say, well, then month 1, I can say that I have a point sitting about right here, right? And then for the last month 5, let's just say, I don't know, it's going to be about here, right? That's about 5. And so then you say, well, let's trace this over, right? Well, this one is about, what? I could say it's month 1, and it's about 40 degrees. These are my 2 points that I'm picking. And then this other one here, I don't know, I'll trace it for now with, I'll say that it's 78 or something, okay? Or something like that. So then I could say that it's month 5 and that the temperature is 78. Okay, so that kind of makes sense, right? I have to pick those points. And so what do? Well, now I have to find how slanted the line is, right? So it's warming up by month, right? By May, it's getting warm. So now I have to figure out my slope. So let's go back, maybe do the color back here. So I say slope. Well, m is just simply change in y, right, over change in x. I try not to make this part too complicated, right? We can make it overly complicated, but if I think of myself riding this line, right, so I can make myself a little stick figure here, and I'm riding the line while I'm going up, right? How much did I go up and y? If I'm going left to right, there's a normal way that we read in English. Well, I went from 40 all the way to what? Well, I went to 78, right? So I went up 38. So I have 38 here. And then on the bottom here, how much did I move over? Well, I went from month 1 to month 5, so I moved over 4 months. And if I reduce that, then I have what? 19. Is that right? Yeah, 19 over 2. That's my slope. Now, let's see where I would cross the y-axis, right? So this would be at month 0. So I suppose if I did this right, then January, then I suppose the actual 0 over here, right? It's kind of funny, but that would be December, I guess, right? So I have y equals mx plus b. Okay, that's what I have. And y-axis here is functioning as my temperature. I don't have to worry about that right now. Axis functioning as my months. So let's plug in some of these numbers, right? Let's pick this one right here. We'll say this is my x and this is my y, right? 1 and 40. So we'll put 40 in here. And maybe I'll change this actually to red again. Okay, so I say, okay, that's like my 40. And what is my m? Well, my m is 19 over 2, so I'll put 19 over 2. What is my x? Well, my x is simply 1, right? And then I have plus b, which is my y-intercept. So I need to isolate my b. Well, how do I isolate my b? Well, it's not hard, right? I mean, when we think about it this way, and I picked a pretty easy number, so I can subtract 19 over 2, or 9.5, okay? So I can subtract that, and if I subtract from there, I just subtract it from this side, right? So that will give me my b. So now what is my b? Well, I get my tail off of here. b, right, because this canceled right here, is going to equal simply, right, what is 40 except for 40 over 1, right? Well, 40 over 1 is also 80, right? If I can fix my 80 here, 80 over 2, right? And it's subtracting 19 over 2. What's 80 minus 19? Well, it's almost 80 minus 20, right? But it's not, so 61 over 2. Okay, here I'm going to 61 over 2. So about, what, 38 degrees. Okay, so then if I rewrite my formula or my equation on my line, I would say that y is equal to, right, 19 over 2 x, and then I'd say plus 61 over 2, right? So that means my temperature is increasing 9.5 degrees per month starting in January. Okay, but then if I want to replace these with actual numbers that make sense, well, my temperature is actually my y-axis, so I might want to say instead T here, and then over here, I want to say 19 over 2 again, right? You could write 9.5 if you want to. And then X, that was my month, right? So I could say month, so M, and then plus 61 over 2. Okay, and when you get an answer in the book or whatever, your answer may not be exactly the same, and that's fine. If it's close, within, I don't know, pretty close. If it's 9.5, if you got 9 or something, or 10, that's pretty close. But you want to be close. All right, so I think that covers it, right? So move on to there, right? We're going to talk about negative angles in vectors. So here we go. So if I have vectors tell me where I'm going and at some quantity, right? So if I'm given this example from the book here, they said, example 2, they said, I have an angle, or I have a quantity of 4, and it's at an angle of minus 210 degrees. Okay, so, right, what do I have to do to get my positive degree? Well, if we remember the circle, right, the unit circle, this is 0 degrees, so I want to remember this, right, that's 0 degrees. My 0 doesn't look very good. This one's 90, right? This is 180. This is 270, and then that would be 360 again, right? Well, you can see, right, if I kept going around, I could get more than 360. Or I could, go backwards and I can start getting negative angles. But either way, right, if I'm facing certain directions, let me just draw, if I'm facing a different direction, right? Minus 210, let's think about what minus 210 means. Well, minus 210 means I'm going backwards from 0, right? So that means I'd be going like this. That's minus 180. Minus 210 means I'm like somewhere over here, right? And I have 4 for my length, but it's minus, right? So what am I going to have to do? Well, I'm just going to have to add something to it, right? Well, what if I'm still facing a direction, one direction, if I add a number to this, right, what's going to happen? Well, if I add this thing, right, then I can, or if I spin in a circle rather, I could spin all the way around and I'd still be facing the same direction, right? So basically, if I have this negative angle here, then go ahead and add 360 degrees, right? So if I add 360 to this, what do I get? Well, I get 4 at an angle of, what's this, plus 360 to this guy up here. It would be 150, and I think we can see that from our graph there, right? I'm facing 150 degrees. So then they wanted to write it in rectangular, right? So I wanted to write it in XY coordinates. So XY coordinates, they said rectangular. So XY coordinates is rectangular. Okay, or right, I said XY coordinates, or you can say it's rectangular, right? So rectangular. Oh my, this is not the neatest here, but that's okay. All right, rectangular. I didn't give myself enough room to write it there. So rectangular coordinates. So what did we say before? We said before, if I want to write them in rectangular, I simply write x is equal to the quantity that I have times, right, always the cosine of it, right, cosine 150, and y is always equal to whoops, sorry, not cosine 150, but cosine of just the angle that I'm given, right? It is 150 in this case, right? And then y is simply equal to a times the sine of my angle that I'm given. So what do I have? Well, I have x is equal to 4 times the cosine of 150. And I have that y is also equal to 4, right? But then it's sine 150. Okay, and this is degrees, right? So I can put a degree symbol here. So you're going to make sure you calculate it in the right mode here. So 150 degrees for both of those. And then if I do this, right, what do I get for my x? Well, I end up getting that I'm going minus 3.46, which makes sense, right? Because I am going backwards when I drew it on the diagram. And then here, I'm going up, and I'm actually going up 2. So I'm going to 2. So you can leave your things like this. What people like to do is to specify what this is. They can leave it like this. This is perfectly fine if you left them like this. But instead, they like to say minus 3.46 r to say that it's going backwards to the right, and then to say plus 2 up. Okay, so that means I'm going up 2. So that would be the measurement of my vector there. I think that pretty much covers it, right? If you think about this, right, what if you had 500, right? So if you have, so over 360 degrees, instead of adding 360, right? Because if you spin in a circle, you're still facing the same direction. Then what are you going to do? Well, you're simply just going to subtract 360, right? Okay, I think that covers it.